Hello everyone, this is section 4.6. So before I start this section again, I want to remind you about the lecture, about the quiz. In case if I sign anything in this lecture, just submit that to 4.6 quiz tab in the Blackboard, all right? Submit your quiz to 4.6 quiz tab in the Blackboard. All right, so you'll find this 4.6 quiz, like I think I showed you on one of the videos. So if you have watched all of my videos, you will see where exactly you can find this. So basically, you can find this on daily submission or something like that. Daily work submission tab you will see in the Blackboard. So if you go inside that, you will see this. This another tab, 4.6 quiz. So just submit your work on this tab. All right. And now, okay, so this section is about optimization. So basically, the optimization. Here we will be doing a few problems which involves with the maximum or minimum, or absolute maximum or absolute minimum. Okay, and the idea of absolute maximum and absolute minimum, I've talked about this on the previous section, I think 4.5 or 4.4, I think 4.5. But yeah, anyway, so let's see the definition of the absolute minimum maximum. Let's just review this one more time. So let's say C is the only critical number in a certain interval. So let's say there is a function. Okay, let's say f is a continuous function on an interval. So let's say there is an interval a to b, and this function is continuous, something like this, and there is just only a critical number. So there should be just one critical number. So so this is increasing. Let's say this is decreasing from just a random equation. So that means this should be, in this case, this should be a critical number, right? So now to find the absolute minimum using the second derivative, all right? So here we will be using the second derivative. Okay, so using second derivative, if we get the second derivative greater than 0 and this C, or in this critical number, then we can say that f of C is absolute minimum. If we get less than 0, then we set maximum, absolute maximum. And the only time we can talk about the absolute maximum and minimum is if we have an interval, and also if there is just one critical number. So in that case, we can talk about absolute, or that this value is going to be either absolute maximum or absolute minimum. Okay. Okay, now here in this section we'll be solving the word problem related with this optimization. So the optimization here, these are the steps or basic steps we are always going to follow. So here, the first step is basically introduce variable, look for relationship among the variables and stuff like that. So this idea is basically we have to change our equation to what we need to, like how we want to use the equation later on. But I will show this idea later on. Basically, first step is basically just understand the problem. Let's just take it, let's just understand it this way. Just understand the problem. The second one, once you get the equation, whatever equation you get, let's say f of x, let's say you get f of x function from the first one. Then the second one is, this function could be anything. Here I'm just saying a function f. Whatever equation you get from here, get the, or find the critical number of that equation. So to find the critical number, we need to use f prime of x, right? And then third one is find absolute extremum. Means we need to find absolute, either absolute maximum or absolute minimum. So to find this, we need f double prime. right? And then at the last, basically use solutions to answer. So at the last, obviously, we have to find the answer. Okay, let's do an example. So this will give a clear idea of what I'm exactly talking about. But before we start the example, let's just see some useful formula. I mean to say useful here. So this means useful. Useful formulas. Okay, so here P of X, or basically when you see small p, or you might see Q as well. Okay, either a P or Q or whatever. I mean, it depends on the equation, what the equation talks about, but something like this is a price. And if you see X, that means a demand. All right, so P is a price, D is the demand, or instead of P, you might have some other variable as well. This is just a variable. But this is price demand function. If we have a price demand function, so the price demand function, let's say if we have something like this, that will be P, and this X items means this will be a demand. Okay, and this R, or R of X, is the revenue, and here we have X, which is demand, and this P of X is the price. So we can also say that revenue, or R of X, is equals to X, as I said, that's a demand, and P of X is the price. Or let's just write it like this: price times demand. Okay, and C of X this is a cost function with C of 0 as startup. Means if there is a 0, then it will be just the initial value of this C of X. Okay, so now here C of X, and there is a bar, right, is the average cost function. So this value I can find by dividing the cost function by X, by dividing cost function by X. Okay, this is just a formula. And again, this now this capital P of X here, okay, this small p of X is price. All right, that's price. This capital P of X here is profit. All right, so profit is equals to, as I said, R of X is revenue. So profit will be the revenue of whatever, well, basically the whole collection minus C of X is the cost. So if a company wants to make some profit, then this should be a positive number, right? So revenue minus cost should be profit. Okay, now let's see an example here then. Okay, so here, let's understand the problem first. Okay, so here an office supply company sells X stapler. So here X, we can take this X as the demand. Okay, per year at some Q, that's the price of each stapler. So this is the price. Okay, so X is demand, P is the price, right? Because we also have a dollar here, so we can automatically think that, okay, this is a price. Now, the price demand equation of this stapler is given. Okay, this is given. So here, now Q is, so as I said in the previous here, there is a P as a price, right? But this can be any variable. This is just a variable. So in this problem, instead of P, I have Q here, but it's still the same thing. So here Q, this is a Q price demand equation where Q is the price, X is the demand. Now we need to find the price. What price should the company charge for each stapler to maximize the revenue, all right, to get the maximum revenue, and what is the maximum revenue? Okay, so basically here we have revenue. So let's change our, or let's find the equation in a revenue form, and then we can work on these problems based on that. So as we said that revenue, or let's just say R, is equals to price times demand, right? Let me just write small d. It doesn't matter. I'm just saying, I'm just writing just a variable, let's just say capital D, doesn't matter. So R is equals to price times D, right? That's what I said here, price times demand. So now, okay, so then let's just use a different color. So let's just write this in terms of, let's say, R of X is equal to price, well, which is Q. We have that equation, right? Q equation is this whole thing, 10 minus 0.001x times D, or demand. As I said, the demand is X, right? So that's why we have even X here inside this parenthesis. The reason is this whole equation is in terms of X. That's the reason we have X here. Okay, now let's find the maximum revenue first, all right? So as we have the equation in terms of R, or we have R equation, let's just say that. Now let's find, or let's distribute this first. R of X is equals to, if I distribute this X here, it will be 10X minus 0.001X squared. All right. Okay, so that's the first part of this strategy. Now, after that, once we get the equation, well, here I have f of x, but in our actual problem, we have r of x, but it doesn't matter. We have a function, right? Now, let's find the critical number of that function. So let's find the critical number of this function. So we can find the critical number by taking the first derivative, right? So when I take the first derivative of this, well, 10x will be just 10 minus there is x squared, so this will come down here. So 0.001 times 2 is 0.002. X to the power 2 minus 1 is still 1, so we don't have to write that. All right, now once we get this equation, now I can find the critical number by assuming this equals to 0. Then I get that, okay, R prime is this, 10 minus 0.002x is equals to 0. So x is, well, I can move this to the other side, so you can do that part. But anyway, the x value here, you will get 5,000. Okay, so once you get this x 5,000, so that means, well, let's check it first. Okay, so here we are trying to find the maximum revenue, right? So as we know that we can find the maximum, so I talked about here all the way down here. So I can find the maximum if I get f double prime less than 0. Okay, so if I get f double prime less than 0, so let's see if I get the f double prime less than 0 or not. So in this case, r double prime. So r double prime of x is equals to, so we have r prime of x. So when I take the derivative of this again, so it will be just, so derivative of this 10 is 0, so we don't have to write that, minus minus. So derivative of this whole thing is, well, when I take the derivative of x, it will be just 1, right? So we just have 0.002. Well, yeah, now this is less than 0, or it's a negative, right? So that means, so this means we can say that as we are trying to find the maximum revenue, right? So the maximum revenue, as we know, the revenue function is right here. So that means once you get the value of X here, so we need to sell this much stapler to get the maximum revenue. All right. And the reason we're saying it is maximum is from this reason, because we get a negative number. So if we get a negative number, that means it is a maximum, right? If we get a negative, double prime is negative, then we get a maximum, right? So yeah, this one says it is a maximum. Okay. Now, okay, so now to get the maximum, now I can plug this into this equation. So R 500 or 5,000 is maximum revenue. Okay, so now we can find the value of this R 5,000 now. So plug this into this equation, or these two are same thing, right? Or you can even plug this into this equation, doesn't matter. Now, if I plug this into this equation, then we will get 10 times 5,000 minus 0.001 times 5,000 square. So use a calculator and you should get 25,000 here. Okay, so yeah, we got this part, right? Now on this one, it is asking at what price should the company charge for each stapler to maximize their revenue. So at what price? So as we have this price equation right here, okay, so using this price equation, well, we can find this price, right? Because we already know the value of X, right? So we need to sell this much stapler. That's the maximum stapler we can sell to get the maximum, or we can, well, we can find the value of price to maximize the revenue, right? So 10 minus 0.001, and X is, oops. Okay, so now this part again, use your calculator or get the answer. So let's make this a quiz problem, right? So this one, easy one. So just use your calculator. When you write, when you submit your work, please make sure that you write this whole thing. All right, this whole thing, and just write your answer. So again, the whole point of this quiz is to check whether you are watching the videos or not. Okay, so this is going to be the quiz problem. All right, keep watching the whole videos. I might assign more quiz problem as well. All right. Okay, so this is the price, like I said, here. Okay, so I guess this problem is done. Yeah, that's all we need to do on this problem. Okay, now let's go to another one. Okay, let's see another one. Okay, so here in this problem, okay, so here we have weekly price demand equation. So here X sells X, well, sells X smartphones per week. So this X, again, I can say this X here, because it says that it sells X smartphones. So this means it sells X number of smartphones, right? So that's going to be the demand. So since this is price and demand equation, so Q is going to be the price. So I can say now Q. Well, there might be another variable as well. So if there is another variable, let's say R, then R is going to be the price or the price. Okay, so don't be confused when you see another variable. That's what I did on exam 2 on the last problem. I basically asked same thing from the lecture, but I changed the variable from P to X on exam 2. So I saw that a few of you guys got confused on that, on this, the last problem number 5 on exam 2. So yeah, this is just a variable. All right, so don't be confused on that. So here, since we have a Q, so this Q we're gonna say this is a price. Okay, and here it says now this is a cost function. So CFC, capital CFX, well, this is cost function. Okay, now it is asking what is the maximum weekly profit. Okay, so basically here it is asking a profit, or we need to find the maximum profit. And then after that, we can find the revenue as well. But let's, okay, now let's do this. Okay, since it is asking profit, so let's find the profit function, and then we can find the maximum profit from that profit function. Okay, so as we know that the profit, what is profit? So profit is, well, it's given right here, the profit equation. All right, that's why I said these are the useful formulas. Okay, so profit is revenue minus cost, right? So the profit is RX minus CX or CFX. So profit is revenue minus cost, or I can even say, let's say instead of writing profit, let's write capital P of X is equals to capital R of X minus capital C of X. Okay, so the reason I'm doing this is I'm trying to find the profit equation, right? So, well, this C of X is given right here. That's the cost equation. The revenue equation, it's not given, right? But as we know that the revenue is price times demand, right? Because that's what I even said here. Revenue is price times demand. And we got this from here. Revenue is, or RFX is price times demand, right? So that means we can also get the equation of this. So revenue is price. So price, as I said, the price is this function, right? And since we are writing this whole function, is since our revenue is going to be in terms of X, so we have the function that is in terms of X, right? So revenue is 500 minus 0.4 X. So revenue is price, this is price, times demand is X minus the cost function is this whole thing. So make sure you write parenthesis here. All right, since there is a minus, so this minus should be distributed to both of these terms. Okay, so that's why there is a parenthesis here. There's a 40, yeah, 40 plus 20x. All right, so after this, now I can distribute this negative to both of this, so that will make, if this first one is negative and the second one is also negative, right? Okay, so now after this, okay, we can also distribute this to these two, since we well, this is attached with these, so 500x minus 0.4x squared minus 2 or 20,000 minus 20x. All right, so here we can combine like terms. So I have 500x minus 20x, so that will be 480x minus 0.4x squared minus 20,000, right? So now after this, okay, since we are trying to find the maximum profit, well, we have profit function. Okay, so now I can find the maximum profit. Okay, following the strategy I showed here, right? The strategy, this 4 strategy. So we got we got the first part, right? We got the function that we need. So now the second one, let's find the critical number. Okay, so let's find the critical number. So I can get the critical number by taking the first derivative. So this will, from here we get 480, right? When we take the derivative of this, we get 480. Okay, there's a minus minus. Now when we bring this down here, because we're trying to take the derivative of this, so this will be 0.4 times 2 is 0.8 x to the power, again 2 minus 1 is still, well, 1 on the top, so we don't have to write that, minus the derivative of this number is 0, so again we don't have to write that. And again after this I can find the critical number by assuming this equals to 0. So as we know that the p prime is 480 minus 0.8 x equals to 0. So from here, okay, solve for x, so x will be 600. Okay, now once we get this 600, now let's find, okay, even though the problem is asking a maximum weekly profit, so we still need to show whether this profit or whether at this point or at this number we are going to get the maximum profit or not. So to get the maximum minimum, we take f double prime, right? Or in this case, we take p double prime. So since we have the p prime, so the double prime will be, okay, in this case, this will be 0 minus the derivative of 0.8 times x. Well, the derivative of x is 0, so we only have 0.8. Okay, so in this case, again, this is less than 0. So, okay, keep this in mind. Okay, in case if you get this one positive, that means we get minimum profit. In case, well, in this case now we have this negative. So if we get this negative, that means the profit at this, or if we sell X number of smartphones, then we get maximum weekly profit, right? So this is maximum profit. All right. So the maximum profit, well, we can find the maximum profit or P of 600. Well, plug this 600 to this equation, right? So when you plug this 600 to this equation, well, this is 600 square. Well, do that part and you will get some value here. So that value is 12400 and 0. Okay, so basically once you get the value of X, you can find a lot of things here, right? We can find revenue, we can find profit, we can find, what else we can find? Let's see what equation we have here. We can find the cost as well, right? We can find the cost, how much it is going to cost, right? Even though the problem is not asking, in case if you see what is the cost, then or what is the maximum cost, then once we get this, then we can easily use that cost as well. So yeah, we can find a lot of things once you get the value of X, right? And the next one, well, yeah, the maximum revenue, right? So the revenue function, well, what is the revenue function? Right, well, it's here, right? So we said this is the revenue function, right? We already found that. So let me just do that. Let's not do this on next page. It's easy to see everything in one page. So that's what I'm doing. So I'm doing everything in one page. All right. So once we get okay, X, then I can use this equation. So the 600. So the revenue, the maximum revenue R of 600 will be, this is equals to, so this is the revenue equation. So 500 minus 0.4 times 600 times there is another 600 outside. So that means we need to distribute this 600 to, or we don't have to do that. Let's just do this part first. And you will get something times 600. So the final answer, well, let me just give me a second. Let me just see what I get using the calculator. So 0.4 times 600 is 240. So 500 minus 240 is of course 260. 260 times 600 is 15600. All right, so that means the revenue will be this much, the profit will be this much. Yeah, so if you want to find the cost, we can even say this, the revenue or the profit minus whatever is that. Well, yeah, you can find that, right? We can just basically just, or you can just basically just use this function right here to find the cost, right? Okay. I guess this is all we need to do for this problem, okay? So the idea is, well, here, again, I haven't done anything new here, right? Because finding this critical number, finding this maximum and minimum, we already did this, right? It's just that now there is an odd problem, so we need to understand the problem and find the answer based on what the problem is asking, okay? So as long as, so on these kind of problems, I'll try to make sure that, well, I'll be asking problem where you can use these strategy, all right? So as long as you use these strategy, you can find whatever the problem is asking, okay? All right, so so I guess, well, if you watch the whole videos, you will know whether I assign anything or not. So in case, again, if I assign anything, just submit that to 4.6 quiz. If I didn't assign anything, then you don't have to submit anything. So yeah, just watch whole videos. All right. Thank you.